Okay, so let's solve a few of these equations here. Before we solve this, we really should state some non-permissible values. So we know that x cannot equal -1 because we can't divide by 0, and +1 because we can't divide by 0. Okay, so once we've done that, we can go ahead and solve this. Now, I don't like these fractions, so for me, I prefer just getting rid of the fractions by multiplying by the lowest common denominator, which is x plus 1, x minus 1. And when I do that, some things cancel out. So in this case here, the x squared minus 1 that shares both these factors, so everything cancels. So I'm just left with the 3x squared. This times cancels with that divide. The only times that's left is the numerator. Okay? Equals. So here, when I multiply by x plus 1, x minus 1, the times x plus 1 and divide x plus 1 cancels, so I'm just left with the x up top and this x minus 1 which did not cancel out. Plus, okay, here the x minus 1's cancel. This x plus 1 doesn't cancel, so I end up with 1 times x plus 1, so that's going to just be x plus 1. Okay, so then I can multiply out those brackets and combine like terms. It's going to be a quadratic equation. So x squared minus x plus x. Ooh, that's convenient. That's actually going to cancel out. So plus 1. So I don't think we really need to use quadratic formula here because we end up with 2x squares. Okay, when I take away the x squares from both sides, equals 1. And since this is a perfect square, I can solve this by square rooting. And I'll do it both ways. But here, if I just solve for x, I get 1/2. And then solving for the x, I undo the x squared with a square root. Okay, so this is going to be plus minus square root of 1/2. Okay, and some people like to write this as square root 2 over 2 when you rationalize the denominator. I prefer unrationalized, but that's okay. Now, if I want to use a quadratic formula, on the other hand, I should get the same answer. So I'm just going to do the quadratic formula over here. So to use a quadratic formula, I have to make it equal to 0. I have to identify my a. Okay, my a is 2, my b is non-existent, so it's 0. And c is going to be -1. And plugging into my quadratic formula, I get x equals 0 plus minus square root of 0 minus 4 times 2 times -1. That's going to give me 8, all divided by 4. So that works out to be square root 8 over 4. Take out the perfect square, and I get root 2 over 2. Okay, which is the same answer. So this, I forgot to carry my plus minus through here. Plus minus. There we go. Okay, so there's quadratic formula, or just solving by square rooting is going to give me the same solution. So here, let's complete the square. So first, make it equal to 0. So multiply out those brackets. So we get 4x squared plus 2x minus 3. Actually, we're completing the square, so we might as well leave that 3 over on the other side. Equals 3. Now, we could complete the square with a 4x squared, but since it's actually 4x squared is actually a square, so it's already a square shape, so it might help us out. But it's really much easier if we just factor that 4 out. Okay, and just make it x squared plus 1/2 x plus blank. And that's equal to 3. And completing the square literally means we want to finish off this square. Okay, so I have an x squared. Okay, so that's going to be x and x along here. I have half an x, so I need to make it square, so I need a quarter of it here. I need a quarter of it here. Okay, that makes plus 1 over 4 plus 1 over 4 here. Okay, So that means it makes this area in here, to finish off the square, or to complete the square in other words, okay, to complete the square, this area here has to be 1/4 times 1/4, which is 1/16. Okay, and then we're going to end up with 1/16 to complete the square, or half the middle squared. And then we balance it with plus 4/16, which is 1/4, because we have 4 groups of 1/16. And then solving the rest of this, we end up with our perfect square. Okay, and I'm just going to make this into one denominator, so 52/16. So that's going to 3 times 16 plus 4. I'm going to divide both sides by 4 and solve it by square rooting. So the completed square form allows me to solve by square rooting. So I'm just going to go move it over here. Okay, so I end up with x plus 1/4 squared is equal to 52 divided by 4 is going to give me 13/16. I'm going to undo the square by square rooting, so I get plus minus square root 13/4. Square root of 16 is 4. And then solve for x. Negative 1/4 plus minus the square root of 13/4. Okay, so completing the square looks like that. That's actually kind of a hard one to complete the square with. So if you have the option, you might want to choose like quadratic formula or something like that for this one. But here's completing the square, and the main idea behind completing the square is we're actually completing the square. We're actually making the square by adding in this 1/16. And that 1/16 doesn't belong there. So once we put it in, we just have to balance, but now we have the square and we can undo squares by square root. Okay, so last one here, we can just solve by whatever method we want. Let's try quadratic formula. So to use quadratic formula, I need to make it equal to 0. Okay, so then solve for x. X is equal to negative b, so negative 2mn plus minus the square root of b squared, so 4m squared n squared, okay, minus 4 times a, which is n squared, times c, which is m squared. Okay, well, conveniently, the square root parts cancel out. This is going to be 4m squared n squared minus 4m squared n squared. That's 0. And that's all over 2 times a, which is 2 times n squared. Well, that's just 0. So that's kind of easy. 2mn plus minus 0 over 2n squared. Well, that simplifies. The 2 simplify, the n's cancel out. So I end up with m over n, and that's going to be negative m over n. So I only get one solution. That means that must have been a bounce. Well, if it's a bounce, then it must have also been a perfect square factor. So I think I can actually factor this. So I get n squared x squared plus 2mnx plus m squared equals 0. Well, this can be factored, right? I mean, I can show it can be factored because I know that n squared, x squared, and m squared, and I know the cross diagonal m squared n squared x squared. I know that this diagonal must multiply to the same thing and add to 2m and x, so that's got to be m n x times m n x. That's going to give me the same, and then if I factor this, I end up with x times n, and here I'm going to have just m. Here I'm going to have x times n, and this should be plus m here. Yeah, so that's my factored form. It's going to be nx plus m all squared, and solving that equation, well, this is, if it's equal to 0, I know that it's equal to negative m over n is going to be my x. It's the negative opposite of back divided by front, and there it is. Okay, and that's the same solution that I got in my quadratic formula, except this time I factored it. So we can do this multiple ways. You don't have to choose the hard way. I've shown you kind of some harder ways to do things, but we can always choose whatever is the easiest method that we can see at the time. Okay, this might be easier using quadratic formula for some people. This might be easier solving by factoring for some other people. Okay, this one here, you might want to complete the square like I did, or just plug it into quadratic formula. That will give you the same solution. Okay, here we solve by just square rooting. Okay, or you can do the long way and use the quadratic formula. Okay, both ways work, but we just need to start becoming fluent with this and having some efficient strategies to solve these types of equations.